Hello again. In this video, we're going to continue with section 2.3 on page 36 of your class notes notebook. Exercise 2. Let's do this one together. A car costs $18,000 and it depreciates by $1,700 or $1,700 every year after it's purchased. How many years will it take the value to be zero? So what I'm going to do is I'm going to set up an equation using the y equals mx plus b, or the y equals b plus mt, as in the book. Where y, we want to find a formula for the value since it initially cost $18,000. So its value is what I'm going to let y be, and I'm going to let t be the number of years, because this is every year and we're asking how many years it'll be purchased. So let's go ahead and find that formula. So what would y equal? It would be the initial amount, which is the b, 18,000, minus, it's minus because it says here it depreciates. The value depreciates, so it's going down by 1,700 every year. So 1,700 is the slope, or is the rate of change. So it says since b here is the initial amount, that's what it starts at, and the rate is 1,700. So I just plug it into the above formula. So the question is, how many years will it take for the value to be zero? So we've done this before. So we can just now plug in the value is $0. So we're going to plug in y is 0 for here. And then we're going to go ahead and solve for t. How would we solve for t? I'm thinking this is a plus negative, so I'd actually subtract 18,000 to get rid of that, the constant. Don't worry about that negative there. It's going to all work out. And then we're going to divide both sides by negative 1,700. And then you can use your calculator to find t. It does become a decimal when you divide. Two negatives are a positive, and it's about 10.5882 years. You can leave it like that. If they ask you to round to one decimal place, it would take about 10.6 years for the value to be zero. So when you're rounding, here's the tenths place. If you're rounding to one decimal place, you always look at the number to the right. If the number to the right is 5 or 0, you would make that 5 a 6. You would add 1 to that place value to get 10.6, because it's closer to 10.6 than it is 10.5. If you're rounding, by the way, this is the hundredths and this is the thousandths. If you're rounding to the thousandths place, on the other hand, you would leave that as 10.588. You would not add a 1 to that 8, because the one next to it is a 2, and that is lower than 5. So about 10.6 years. You could also say about 11 years. It's, again, that would be rounded to the whole number, or the nearest year. It's closer to 11 years than 10 years. So let's go on to the next page. Exercise 3. Exercise 3 is practice with this, so go ahead and try this and come back when you want to see the solution. Here's the solution. It says here a travel company is advertising a vacation to Puerto Vallarta. Airfare costs $550 and the hotel costs $55 per night, and including food cost, which is about $40 a night. Let C be the total cost in dollars, so I just wrote that, and lasting D days, so D is the days on vacation. And I ask a question here, how many days? The vacation costs $1,500. So I just went for C and D. I'm not going to use that 1,500 right away. And the equation is 550, which is the initial amount, And then the 95 is interesting. I got that by both of these, if you add it together, is the total rate. How many days of vacation costs $1,500? $1,500. So I'm going to put my $1,500 in for my cost. Now, it really wouldn't be wrong. I didn't do this on the last question, but if you even started with this and didn't ever put a C, since the C is known, you could have just put what the C is. The one benefit of keeping the C is if they have a part A, part B, part C, where there's many different choices for cost, and you want to try each one out. So let's go ahead and solve this. So I subtracted 550 divided by 95, and we get 10. It takes 10 days to add up to $1,500 with this scenario. Exercise 4, we saw in the last video. Without solving, figure out whether each equation has a positive solution, a negative solution, a solution that is 0, or no solution. So see if you can try exercise 4 and come back to see the solutions. Okay, let's do part A together. What are we going to do here to solve for y? We're going to subtract y and they go away. But if you remember, when you get 0 equals 5, that means no solution. Part B. This one's okay. We just divide by -16. The answer's 4, actually. They didn't ask for the answer. They just want to know, oh, it has a solution. It's a positive solution. The answer is positive. Oops. You can see part C is a negative solution. Since they're dividing by the coefficient there, you don't have to worry about writing this down, but there it is. It looks ugly. But you can see the answer is 1 negative is a negative. You might say to yourself that part D has no solution, but be careful there because this is a 5x and this is a 10x. There's x's on both sides. So yes, you're going to subtract, but it's not going to all go away. Kind of weird. We're going to end up with 0. So, this is an example of a 0 solution. A solution that is 0. Great. So this is a review of solving equations. Last exercise, we're going to look at review how to solve for a variable. This one looks tough, but we can do it. When an equation has more than one variable, such as 3y plus 2x equals 6, you can't just find one solution for x. But to solve for x means to isolate x. We saw this in the last chapter. So if you solve for x here, how they got the solution, let's just go ahead and try that one. We want to solve for x, so we're going to subtract 3y. You cannot combine those, so it's just going to be 6 minus 3y, and then you divide by 2. They just left it like that, didn't they? They didn't care about simplifying. Yes, 6 over 2 is 3. You would have to do that though, you would have to split each up in the distributive property, so you have to be careful with that. So they just left it. So you try exercise 5. Pause when you're ready, or pause and come back when you're ready. Here's the answer. I want to solve for h. So first I subtracted over this 2 pi r squared. Don't let the ugliness confuse you. And then we're going to do just like we did over here, divide by the coefficient. And the coefficient is everything in front of the h. So it's 2 pi r8, 2 pi r on this side, 2 pi r on this side. I'm not even going to bother to try to simplify that. So this cancels. So h is equal to 400 minus 2 pi r squared. There's imaginary parentheses here, so you can't just divide these without separating them. If you really wanted to separate them, it would be look something like this. 2 pi r. If you really wanted to cancel those, now you can cancel. So you cannot cancel like this, but once you use distributive property, you can cancel. So another variation of this answer is 200 over pi r minus, now everything cancels except for the r. That would be okay. But just don't cancel those and keep that a 400 there, because that doesn't work. Hope this helps. See you next time.